Ladies and gentlemen, welcome to today's class. We're going to solve more than one Coplanar Parallel Forces. First of all, let us start by making an overview of Coplanar Parallel Forces. Coplanar Parallel Forces are forces that act with the same plane and are parallel to each other. These forces may either act in the same direction or in opposite directions. They are common encountered in physics and engineering, especially in structures and machine mechanics, as they often relate to loads applied on beams, bridges, and other rigid bodies. We have three key characteristics of Coplanar parallel forces. Coplanar nature. They lie in the same plane as in nature. Secondly, parallel alignment. The forces do not converge at the point. Instead, they are parallel to each other. Third one, magnitude and direction. These forces can have equal or unique magnitude and may act in the same direction or opposite direction. We have two types of Coplanar parallel forces. First, we have like parallel forces. Second, we have unlike parallel forces. For like parallel forces, forces that act in the same direction. In like parallel forces, the net effect is the addition of the magnitude. For unlike parallel forces, the forces that act in opposite directions, the net effect is the difference in the magnitude and the resultant force act in the direction of the larger force. The resultant of Coplanar parallel forces depends on their magnitude, direction, and the point of application. It is really depending on resultant magnitude, direction, and the point of application. For like parallel forces, the resultant force is the sum of the individual forces and act in their direction, their common direction. For unlike parallel forces, the resultant force is the difference between the magnitudes and act in the direction of the larger force. The point of application of the resultant can be determined using Variance theorem or moments. Coplanar parallel forces can be applied on too many. First one, in analysis of structures like beams under distributed or point loads. Secondly, determination of the center of gravity in the object subjected to parallel forces. Thirdly, understanding load distribution in mechanical systems, and so on. Here we have an example of four Coplanar parallel forces. Four parallel forces of magnitudes 100 Newton, 200 Newton, 50 Newton, and 400 Newton are shown in the figure below. Determine the magnitude of the resultant and also the distance of the resultant from the point A. They give us data. Force at point A will be equal to 100 Newton. Force at point B, 200 Newton. Force at point C, 50 Newton. Point at the point D. Force at point D is equal to 400 Newton. The distance AB 1 meter, BC 1.5 meter, CD 1 meter. The distance AB, because our forces are in the same plane but different direction. It means two are negative, other two are positive. Let I choose the clockwise direction as positive direction. The resultant force will be equal to the summation of all forces, which is equal to 215 Newton. For finding the distance where the resultant are fixed, we have to use the law of moment. Now take a moment of all force about point. The force of 100 Newton is passing hence is passing A. Hence the moment about A will be 0. Moment of 100 Newton force about A is 0. Moment of 200 is equal to A times AB. 200 times AB equal to 200 minus 200 Newton meter. Moment of 50 Newton force about the edge equal to 50 times AC is equal to minus 125 Newton meter. Moment of 400 force about A equal to 400 times AD equal to 400 times 3.5 equal to 400 Newton meter. Then the moment of resultant of 250 Newton about A equal to, let us say, the distance as y. It is 250 times y as distance equal to 250 y Newton meter. Then for finding the distance, we have to equalize the moment of forces by the moment of resultant. Resultant times y distance equal to 1075 Newton meter. Then y as distance is equal to 4.3 meters. Thanks for attending the classroom. Let us meet the next time.